In this problem, we'll be going over impulse and momentum of a car collision scenario. In this diagram, we have labeled our north, east, south, and west direction, and labeled our positive y to go up and our positive x to go right. And where we were given and shown two cars, car A and car B, where car A is traveling due north 20 meters per second with a mass of 1,200 kilograms, and car B traveling due east at 15 meters per second with a mass of 1,500 kilograms. So for our problem statement, we have two cars colliding at an intersection. Car A was mass 1,200 kilograms that is moving 20 meters per second towards north, while car B with a mass of 1,500 kilograms is moving at 15 meters per second towards the east. These two cars collide and stick together upon impact, forming a single combined mass. In this problem statement, we'll be finding the final velocity and direction of the cars after the collision. To go over some given assumes, for the assumes, we can take that the mass of the drivers are negligible, and so is air resistant. The cars act like a particle, and that this is a perfect inelastic collision, and that there's no friction from the road, and that this is a closed system, meaning that the mass is conserved throughout the collision, so no debris or mass is being lost, and that the cars meet each other perpendicularly. And to go over some of the givens that we went over, velocity of car A is 20 meters per second due north, with a mass of car A of being 1,200 kilograms, and the velocity of car B being 15 meters per second due east, with a mass of 1,500 kilograms. Some of the formulas that we'll be using for this problem is the conservation of linear momentum and impulse and momentum equation. But for the impulse and momentum equation, since car A and car B apply equal and opposite forces on each other, the impulses cancel out for the whole system, meaning that we can just directly apply the momentum conservation formula directly. So for our solution, we take the momentum of the x direction, and since for the final x direction, they'll be the same since it's a perfect inelastic equation, we can write the formula like this. And for velocity of car A in the x direction, it is 0 because it only travels due north or plus y direction, so there's no contribution in the x, which leaves us with the velocity of car B in the x direction to be 15 meters per second. And once we plug all that in, we're left to try to solve for velocity final in the x direction, which when solving for it, we get 18.33 meters per second. We apply the same logic for the y direction, which leaves us that velocity b in the y is now 0 since it only moves in the east or plus x direction, and leaves us with velocity of car A in the y direction to be 20 meters per second. So once we plug this into our formula for the y direction, we get that we need to solve for final velocity of y, which gets us to 8.88 meters per second. Now to solve for the final velocity and direction, we apply Pythagorean theorem for the velocity. So we take velocity final of x squared plus final velocity of y squared, all squared, and we plug in our values to get that final velocity is equal to 12.18 meters per second. And now for the final direction, we'll be basing our angle with respect due to the east axis, or you can say the plus x axis, so that we take theta equals inverse of tan times velocity final y over final velocity x, which gives us an angle of 46.85 degrees with respect to east axis or plus x axis.